Hey boys, welcome to today's lesson. Today we're going to go through simultaneous equations. The first lesson will be on substitution, then we'll go into elimination. Mr. Michelangelo has told me that this is pretty much a revision for you, but it might have been a little while since you saw this. So first of all, what do I mean by a simultaneous equation? Well, for example, I might ask you to solve the equation or the linear equation x plus 3 equals 7. Now on its own, that would be a very easy solution to make, right? So you subtract the 3 and make it 7 minus 3 is 4 and x equals 4. That's not a problem for a linear equation. But what if I gave you the question x plus y equals 7? Do you see a problem with this equation on its own? The main issue I see with this is that there are infinite amount of responses. Okay, for example, x could equal 1 and y could equal 6 because 1 plus 6 makes 7. We know that x equals 2, then y would equal 5, for example. That will still equal 7. I could start dealing with negative numbers on both sides, decimals, fractions, recurring decimals. On its own, it's not going to work. So in this second style of question, what we need is another equation, because at the moment that is what we call a linear equation or a straight line. If I put in the form of y equals minus x plus 7 and I sketch that graph out, that will look something like this. It's a negative gradient and it goes up 7. Okay, so it goes through positive 7, it's a negative gradient, look like that, right? You can see that there's so many different solutions on that line that go on forever. So what we kind of need is another equation to go with it that then gives us a solution that works for both equations. I could say something along the lines of 2x plus y equals 8, and then I could find a common y value and a common x value that would work for both equations. That's the nitty-gritty of it. In year 8, you would have gone through the solving via graphical means. We want to look at this algebraically. There are two main methods that we use algebraically. Today we're going to look at the first one, which is substitution. So these are the three equations that we're going to look at. Because you're an accelerated class, I've gone through two linear and I've branched into a non-linear equation as well, which obviously we're going to be revising down the track. If you want to pause it and have a crack at these questions, you're most welcome to. Otherwise, listen on and we'll go through it together. Okay, so look at question 1. So there are a number of ways that we can solve this. As I said, we could do it graphically, like we just shown. We could do it what we call elimination, or what we're using today, which is called substitution. Now, you remember that substitution basically means we're going to replace a letter with a number, or replace one letter with something else. So in this instance, what it means by substitution, we know that y has a value of 3x. That's what y has a value of. So what we can actually do, we can take this 3x and in the below equation, the second equation, we can sub that 3x into the y value because they have the same value. Let's call it equation 1 and equation 2. So basically we're going to substitute y equals 3x into the second equation. Now why might we do that? Well, let's see what happens when we do that. We get the x plus, now I take the y out and I replace it with this 3x. And I have that equals 7. Can you see why we've done that? Well, hopefully you can see that now we only have one variable, one pronumeral to solve for. X plus 3x equals 4x. So 4x equals 7, okay? And now all I need to do to find my solution is I need to divide it by the 4. And I get not a very nice solution, albeit I get 7 over 4 as my answer. Okay, now, remember, it's a simultaneous equation, which means we only have the answer at the moment to one variable, but there is a second variable there. So we have this second variable that is y. Now we have two different equations. We could choose one or two to put it in. I'm going to choose, let's say, equation 1. I feel that's quite easy because all I'm going to say is that y equals 3 times whatever x is. That means y equals 21 over 4. And we now have our two solutions. I'm going to highlight those two solutions there. Of course, we can also write this in the form of a coordinate. So for example, we could write it as 7 over 4, comma 21 over 4, or mixed numbers, decimal places, whatever you want to have. But that would be my solution. Okay, and of course, because these are actually two equations, we can say that it's the same as finding the point of intersection, which is the common x and y value there. Okay, so that's the first one. Let's look at the second one. Now, of course, sometimes you'll see when we look at the elimination, it depends on what the question looks like as to which method you might use. The first method really lent itself to substitution because I had a straight value of y is equal to. The second equation, also the same, it's y is equal to. We might use elimination down the track for this question, but certainly substitution is not bad. Why do I say that? Well, if we look at the first and the second equations, the first equation says that y is equal to 3x, similar to that last question, which means I can take this 3x and simply plot it where that y value is. I can substitute it, okay? So if I do that, let's do it in purple, this one, we get 3x, that's what the y value equal to, and then it equals to x plus 8. All right. Again, you can see now we've created a normal linear equation. I'm going to subtract the x to the left-hand side and subtract it there. That makes 2x equals 8. This is a much nicer solution, of course, because in this case, when we divide the 2 across, x will equal 4. Just remember, when you have your simultaneous equations, be really careful not to forget about the second solution. Again, in this case, it's the y value we need to look for. Let's use a second equation this time. Y is equal to x, which is 4, plus 8. Therefore, y is equal to 12, and I have my second solution. If I wanted to, I could have used the first one and said 3 times 4, which you can see still equals 12. So it doesn't really matter which one you use. Again, I'm going to highlight those two solutions, and that would be satisfactory for my answer. But I'm also going to write this as a coordinate in the event that we're trying to find a point of intersection. So again, two really easy ways to use the method of substitution. Now, number 3, I've now delved into a bit of quadratics. Hopefully you remember your quadratic equations from last year. We'll see if you do. Again, similar type of question, right? Because I have this y is equal to x squared. Anytime I have a letter equals, substitution works really nicely. So I'm going to take the x squared and I'm going to simply plot it where the y is. So in this case, we have 7x plus x squared equals 8. Now, of course, when we're solving a quadratic equation, we want to make it all equal 0. We want to have it in the form of ax squared plus bx plus c equals 0. So I'm going to do that now. I'm going to make it as x squared first of all. I'm going to put plus the 7x, and I'm going to pull the 8 across to make it a minus 8 equals 0. Now, using either the cross method or the product sum method or PSF method or whatever method you want to use, I'm going to look at this and say my product, I'm just going to do scaffolding for this one, is -8 and the sum is 7. So my numbers pretty much look like, let's make it 8 and -1. That looks about right. Okay, 8 minus 1 makes 7. I times them to make -8. And because it's a monic quadratic, I'm going to go straight into my answer as x plus 8 brackets x minus 1 brackets equals 0. It's a quadratic equation, so we're going to solve it. We have x equals -8, and we have x is equal to 1. You could use a quadratic formula as well. Now, this again, you need to make sure you don't forget about the y values because there's a second solution. We've got two different solutions this time. We have two x values, which means we're going to have two y values as well. So let's look at the second equation, much easier to use for this because it says y is equal to x squared. Well, -8 squared is positive 64 and 1 squared is 1. And they are my two solutions. Now, whenever I have a quadratic where I have two solutions like this, I like to circle them or really clearly identify which x value goes with which y value. Don't just put x equals the two values and then y equals the two values because then I'm going to ask you, well, which one does the y belong to? Which x value? Likewise, I could write them like this, -8 and 64. I could write that as 1 on 1. Now, why do we have two solutions when we have a quadratic? Well, hopefully, if you think about this as an equation, I'm just going to make, we'll do y equals x squared looks like this, okay? And then we've got, let's put it in general, or y-intercept form, y equals -7x plus 8, okay? So it's going to be something like this. What we're seeing here is we have two solutions, 2 points of intersection. That's the coordinate of 1, 1. And this is the coordinate, of course, of -8 and 64. And so you can see that's why there are two solutions. Whereas previously, if we looked at those two straight lines, there's only one point of intersection. So I hope that kind of makes sense. Look, that's pretty much it, to be honest with you. It's 10 minutes of substitution. I think substitution for the most part is pretty easy. The only question I'd probably be cautious of that I haven't sort of spoken about is this question here. Something like x plus y equals 10. I'm going to make this so it probably won't work too nicely. And then y equals, actually we'll make it a negative. That's pretty much what I want to look at. Y equals x plus 3. Just be mindful of this question. There's a reason for that, and it is the negative. Likewise, you can see previous the last couple of questions, substitution works really nicely because I have y is equal to. I'm going to basically take that x plus 3 and I'm going to plot it straight into what that y value is. Now, what I get is this, right? And hopefully, me doing that, you're yelling at me and saying, "Sir, you've made a mistake," because I have made a mistake. When I sub that x plus 3 in, that y value had the negative in front, which means the negative works on the entire thing, which means now that becomes correct. Don't forget that. If you wanted to just write straight away, x minus 3 equals 10, then by all means go for it. Now, I'm not going to solve that solution because you're going to see there's another problem with that where the x's cancel out. But I want to show you that's the kind of thing that we're looking at, all right? You just got to be careful of that substitution when you put that into your question, all right? Hopefully that makes sense. Let's put a little 2 in front of that just so it looks a little bit nicer and it might actually work. Because now, of course, I can then say x minus 3 equals 10. I can plus the 3 across and make it x equals 13. I can then sub it back in to find the y value of 13 plus 3. I get y equals 16. And look at that, one little change makes it all work nicely. Look, that is substitution. So remember, clearly identify your two equations. If it says y equals or x equals, then substitution works really nicely. We simply replace it into the other equation where that variable might be and solve it, ensuring, of course, that you get your two different solutions for your variables. If you do get the quadratic questions, make sure that you're going to have 2 pairs of x's and 2 pairs of y's. Okay, hope that made sense. Have a crack at the work today. Any problems, please shoot me a message through Canvas or, of course, your own teacher. Have a wonderful day.